Today in Capechi's Corner, we're going to look at equations of parallel and perpendicular lines. So let's first look at some vocabulary. So when we're talking about a reciprocal mathematically, it's simply switching the numerator and denominator. So 3/4 becomes 4/3. Same thing with 1/3, you just switch them and that would end up being 3. And if you have 4, which is really 4/1, it become 1/4. All right, so parallel lines, you know that they never intersect. In this case, when we're talking about in terms of algebra, the slopes are the same. When we're talking about perpendicular lines, we know that they make four right angles. The slopes are opposite the reciprocal. So for instance, if we take something from above that we just did, we take the reciprocal and take the opposite sign. So for instance, if something was negative, it then becomes positive or vice versa. Okay? So we're going to write equations of parallel and perpendicular lines. The slope is going to be super important as we're going forward. Okay. So let's look at example 1. Again, I put the point slope form here in case we need it. It says write the equation of the line that passes through the given point and is parallel to the given line. So basically what that means is I have a line and I have a point. And I want the equation of the line that goes through that point that I'm giving you and is parallel to the given line. So we know that the slopes have to be the same. Okay. So for instance, looking at letter A, this line has a slope of 3. So we don't really need that negative 5 for anything. So I'm going to take my point, which is not a y-intercept. So I'm going to have to use point slope. So I'm going to take y minus 2 is equal to my slope. Again, is going to be the same as my original equation, which is 3, and then x plus 4. I'll distribute, and I get 3x plus 12. Add 2 to both sides. We always leave things in slope-intercept form unless we're told otherwise. So 3x plus 14. Okay, let's look at one that involves the slope being a fraction. Same idea. So I have y plus 2. And then my original slope is 3/4. So my slope is going to be the same for a parallel line. And then I have x minus 8. So this gives me y plus 2 is equal to 3/4 x minus 3 times 8 is 24 divided by 4 gives me 6. I'm going to subtract 2 from either side, and I end up with y is equal to 3/4 x minus 8. That's my equation that goes through the point that they gave me here and is parallel to the given line. Okay, so now we're going to look at the opposite. We're going to look at some things that are perpendicular. So again, we have to make sure we're okay here. So my given line, so again, here's my line. Here's my point. This time I'm not looking for something that's parallel, but something that is perpendicular. So I'm looking for the line that is parallel, that is perpendicular to the line and goes through that given point. All right, so the given line is 2, right? We're getting that from there. So the slope that I have to use is opposite the reciprocal. So my sign was originally positive. It's now going to become negative, and then I took the reciprocal. So again, now I'm going to use my point. So I have y minus 5. I'm going to use my new slope that I just found, and then x plus 4. So I end up with y minus 5 is equal to negative 1/2 x minus 2. I add 5 to both sides, and I'm left with y is equal to negative 1/2 x plus 3. All right, let's take a look at our next example. Now, our next example, the equation was not in slope-intercept form yet, and I have to put it in slope-intercept form in order to find the slope. So I just did it kind of ahead of time to save some time, moved the 3x over, divided everything by 2. So here's the equation that I want this point, the given point, to be perpendicular to. So the slope here of my given line is negative 3/2. So the slope that I have to use is opposite, meaning it'll be positive, and then I'm going to take the reciprocal. Okay, so I'm going to use this point that it's going through, right? So I have y plus 2 is equal to 2/3 times x minus 1. So I have y plus 2 is equal to 2/3 x minus 2/3. Okay, so I'm going to subtract my 2 from either side, and you can use your calculator to figure out what that is, but I have y is equal to, if you can't do it in your head, 2/3 x, and this is going to be minus 8/3. So that is my equation of the line that is perpendicular to this given line here and goes through the given point. Okay, in our next example, the question is, are the graphs of the equations, and they give us two lines, which are equations, parallel, perpendicular, or neither? So again, to save some time, I put this first equation in slope-intercept form. You can't answer this question unless you have them both in slope-intercept form. The second one was already in slope-intercept form. So now I'm going to compare the slopes. This has a slope of -4. This second equation has a slope of -1/4. So although they are the reciprocal of one another, they're not opposite. They both have the same sign. So that one's going to be neither. They are neither parallel or perpendicular. Okay. In this example here, they are already in slope-intercept form. So I have a slope here, which is 2, and I have a slope here, which is -1/2. In this case, they are opposite. One's positive, one's negative, and they are the reciprocal of one another. So these lines, if we were to graph them, they are perpendicular. Okay, let's look at the next example. Again, the first example is already in slope-intercept form. The second one is not, so I put that in slope-intercept form. They both have the same slope with different y-intercepts, so we know that these lines, if we were to graph them, are parallel. Okay, moving on to our last examples, it says determine whether lines P and T are perpendicular by finding the slope of each line. So again, looking at the lines, I did kind of go ahead a little bit just so we could graph them. So this blue line here, the slope, we went up 3 to the right 4. So up 3 to the right 4 gives us +3/4. And at this pinkish line, I went down 4 to the right 3, which is -4/3. So these slopes are opposite and they are the reciprocal of each other. So we know that they are perpendicular. All right, looking at the next example, again, looking at the blue line, I counted up 4 to the right 3, up 4 to the right 3. And for the pink line, we went down 5, 1, 2, 3, 4, 5 to the right 4. So down 5 to the right 4 gives us -5/4. So when looking at these slopes, they are definitely opposite. One's positive, one negative, but they're not the reciprocal of one another. So they are not perpendicular. So we're going to say not perpendicular to one another. Okay. All right. Thanks so much for stopping by today. You have a great day.